Hey guys, welcome back to Unit 5, Polynomial Functions. We are going to cover page 5 today, and if you don't have a calculator, please go get one. A little reminder is make sure you turn on your diagnostics because you are going to have to give the correlation, and correlation is the R square value, okay? And you might want to get a ruler if you like to make straighter lines for your graphs. So, let's read the direction. It says, use the given data to find a linear model. Give the correlation, sketch the graph, and predict the distance at which there will be no water. When there's no water, that means, notice water in the yard, that's going to be your y distance from the flooded area is your x. So no water is where x will be 0. Okay? I'm so sorry, I got that wrong. Where y will be 0. Because that's going to be the water in the yard. Water. All right, so let's get started. Now, before you start, you might want to get an idea of what correlation you are going to use. But since this time I told you to do linear, you don't have to figure out, you don't have to do successive differences at all. You can just go and plot. All right, first things first, let me clear. Make sure you have your diagnostics turned on, okay? So if you hit mode, right here, this is mode, go down until you see diagnostics, stat diagnostics. Make sure on is highlighted and push enter. Number 2, because you are going to be plotting these points and then you want a linear regression to help you determine what the answer is for your question, you need to go and turn on your stat plot. So if you hit second, y equal, that's your stat plot. Notice it says L1 and L2 and it is on, okay? I like to always turn it on and then look through here and make sure I have all the points I wanted. Now I don't have a lot of data, so I could probably use this box, but if you have a lot of data, you might want to use the point instead. That's just the choice you make, and for this reason, I'm actually going to just show you the difference and take the difference into and use the plus, okay? And it's just how you plot points. All right, now let's enter our data. Hit stat, go to edit. I'm going to clear information. If you highlight the title, the label, and hit clear, it will clear it for you. And push enter. All right, let's go ahead and enter. L1, that's our x, is going to be our distance from the flood. So you got 2, 4, 6, 8, 10, 12, 14, 16. Right click. Distance from the yard, water in the yard, 2.1, 1.8, 1.9, 1.6. I notice it's going down as your x is going up. Okay? You can put 1 or 1.0. All right, it says use the linear model. So hit stat, right click, go to your linear. You probably would rather use this one instead of number 8 because this looks like mx plus b, and you are more familiar with that. All right. Now, when you get to right here in the other video, you notice I didn't do alpha trace because I was not graphing. Now I am graphing. So let's go ahead and hit alpha trace. I'm going to store it in Y1. Excuse me. Okay, say enter, calculate, and there I have my equation. All right, I'm going to go ahead and write the equation. So my equation is y equal negative 0.063. 3 decimal places would be wonderful. X, what is your b? Plus 2.143 with an r square value of r square, not r. Okay, make sure you look at the r square. 71.5%. So there you have your equation. All right, now we're going to plot some points. So that we're going to sketch the graph and then we're going to predict the distance. All right. I'm just going to use the first quadrant. Here's your y, and here's your x. Okay. Now, label. Right here is your distance from flooded area. And that is in feet. Have a title, okay? I'm just going to call it, let me see, what do you guys want to call it? let's just call it just measurement of water. Okay, float stage, if you want to do that. Just give it some sort of title. All right, and this distance is in 2, 4, 6, 8, so I can just go starting at 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, okay? I really only had to go to 16, but I did it further. And now this is water in yard, all right? Notice it starts at 2.1, 1.8, 1.9. It's starting at 1. So what I'm actually going to do is, I'm going to put a little breaker. I'm going to call this one 1, okay? Then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be 2, and so forth, okay? So right here would be 1.5. 1, 2, 3, 4, 5. And there's my graph. Now, could I have sketched my graph differently? Absolutely. All right, now let's go ahead and plot the point. At 2, I am at 2.1, about right there. At 4, I'm at 1.8, about right there. 6, 1.9. 8, 1.6. 10, 1.2. 12, 1.4. 14, 1. Did I say 12? Let me see. 10 is 1.2, 12, 1.4, 16, 14 is 1.6, and 16 is at 1. All right? Now, notice this is your y-intercept. I'm crossing my y-axis is about 2.1, so about right here. Okay? All right, now I'm going to make a sketch of my linear. Notice it's a negative, so it's going to slope. Yes, about here looks right. All right, so there's my sketch. Now I'm going to predict at where there will be no water. So that means I want to know what my x value is when y is equal to 0. Okay? So you can do it different ways. You can plug y here, put a 0 there, and solve for x, or you can use your calculator to help you. I'm going to hit zoom 9. Zoom 9 is zoom stat. It's going to plot every one of those points for me. Now notice, I'm looking for a point over here, and it is not on the graph, and that's an x value, okay? So if you hit window, go check your x value, 17.4. You might want to go a little higher. I'm going to go ahead and do, not that one. I'm going to go ahead and do 30. Increments of 2. 2, 4, 6, 8. Let's do increments of 30. Okay? The minimum and the maximum, the minimum's going to matter because I wanted my y to be 0, so I'm going to make that a negative 10. The max doesn't really matter to me because I'm looking at this point down here. And now I'm going to graph. Notice I still can't see where that is. Okay? So the best thing to do is go back to window. Instead of 30, let's make that 50. And I think I've kind of gone too far on the y. And now hit your max. Hit your graph. All right. This is what I'm trying to find. That is your x-intercept. That's your 0. That is what's going to tell you when there is no water. Okay? So your y is going to be 0. So if you hit second, calculate. You see how that's a 0? X-intercept, hit 2, left bound, right and left arrow, go to the right of the intersection where it crosses the x-axis, hit enter. So it needs to be 33.96 feet to have no water. And there's your solution. Or you can write it like this to show you ordered pairs. And there you have the answer to that one. All right. Second one. Here we go. It says, use the data given to find a quadratic model Give the correlation, sketch the graph, and predict how much money will in the bank in 20 years. This is your x value. So x is going to equal to 20. Now I'm not going to do successive differences. Why? Because I already told you what model to use. So we're just going to enter the data, go to Stat Edit. Okay, I'm going to clear all that so I don't accidentally have extra numbers. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Right clicked over. Let's enter the money in the bank. 1100, 1201, 1400, 1920, 2800, 4250, 6675, 10121, 13245. For every x, make sure you have a y, make sure your numbers are correct. Okay. Now, we're going to right click to quadratic, which is number 5. I am going to store this because I'm going to have to use it to find my information later. And I'm going to calculate. Go ahead and write your equation. Y equal 276.433 x squared minus 1293.996x, running out of room, plus 2462.05 with an R square value of 99.6%. Alrighty, so there's my correlation. Now, let's make a sketch of the graph. Okay, just like we did before. Let me move it over. There's your x, there's your y. Alright. Let's go ahead and give it a title. I'm going to call it Money in the Bank. Always give it a title so you know what it's kind of about. Years from present. So right here, I'm going to put years from present. So right now it's 2017. So this one will be 2018, 2019. Okay? But you don't need to worry about that. So I'm just going to put 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, and 10. All right. You can do it like that. Money in the bank. Okay? Our lowest number is 1100. Our biggest one is 15,000. So 1 to 1,000. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So we're going to go 1, 2, 3, 4, 5,000. 6, 7, 8, 9, 10,000. And 15,000. Okay? There we go. All right. Or you could have wrote 5, 10, 15, and put in thousands. Either one would work. At 1, it is at 1100, so it's about 1,100. Next is 1,200. Next is 1,400. Next is 1,900, so closer to 2. 5 is halfway up. 6 is almost to the 5,000. 7 is above 6,000. 7 is getting higher. 8 is at 10,000. See, 1, 2, 3, 4, 5, 6, 7, 8. Okay? So 9 is at 13. All right. Kind of see the curve a little bit? Come off a little. Okay, there's my quadratic. All right. Now, it says, predict how much money will be in the bank in 20 years. 2 different ways to do it. X is 20 years. You can plug it into that, or you can go ahead and do it this way, okay? Another word for X is the word value. All right. So, notice I entered it. I'm going to zoom 9 so I can kind of plot everything, okay? My X value is 20, so check your window. Look at your X maximum. It's only at 9.8. How about we do 25? And it's just kind of scooch the graph over from 9. Right now it ends in 25. Now, hit second count. You see where it says value? That's an X. So hit 1 and type in 20. So in 20 years, this person will have $87,155 $0.29. 87155.29. That's how much they're going to have in 20 years. Okay? So there's their money in the bank. Notice the growth. The more you have, because you kept longer, you have time. So you guys, if I were you, I would start saving right now too. Good luck. I will work on the next page. Bye.